Hello students, welcome to this lectures of M.Sc. Part 1 Mathematical Methods in Physics. So in this lectures we are going to discuss Fourier integral theorems or the proof of this Fourier integral theorem. So statement of this theorem, that is f of x is equal to 1 over 5 integrations from minus or 0 to infinity f of t dt and minus 2 plus infinity cos mu t minus x into t minus x du. Okay, so this is a statement of this Fourier integral theorems. Okay, so we are going to prove this Fourier integral theorems. So by considering the Fourier series. Okay, so we know the Fourier series, that is f of x is equal to a naught over 2 plus summations n is equal to 1 to infinity a n cos n pi x over c plus summation n is equal to 1 to infinity b n sin n pi x over c. Okay, so now this Fourier series we expand for the function if it is periodic. Okay, and this Fourier integral we apply for the non-periodic functions. Okay, so this f of x maybe it is non-periodic, and for this when we expand the functions by using this series Fourier series, then functions is a periodic. Okay, so here we know the Fourier constants. So here x is a variable things, and interval, that is we take there minus c to plus c. Okay, so Fourier constants we know very well, that is a naught is equal to 1 over c. Okay, this is arbitrary constants. Okay. Integrations from minus to plus c f of t dt. Okay, so here we x, this x we change is equal to t. Okay, and a n is equal to 1 over c minus 2 plus integrations f of t cos n pi t over c and dt. Okay, and the b n is equal to 1 over c integrations minus 2 plus f of t to sin n pi t over c to dt. Okay, so this is equation number first. Okay, so a naught, a n and the b n, these are the Fourier constant. So I am going to substitute this Fourier constant into the equation number first. So if I substitute, then the f of x become is equal to a naught, this a naught is equal to 1 over c, so it is 1 over 2c integrations minus 2 plus c f of t dt plus summations over n is equal to 1 to infinity a n is equal to 1 over c, so 1 over c integrations minus 2 plus c f of t and the cos n pi t over c, okay, into cos n pi x over c. Okay, so cos n pi x over c into dt, and for this plus summations n is equal to 1 to infinity 1 over c integrations minus 2 plus infinity f of t sin n pi t, n into pi t over c into sin n pi x over c into dt. Okay, so this is expressions after substituting this a naught, a n and the b n's. Now take out this 1 over c integrations minus 2 plus in c f of t is common, so it is 1 over 2c integrations from minus 2 plus c f of t into this cos n pi t divided by c, the cos n pi x over c plus sin n pi t over c into sin n pi x over c, okay, into dt. Okay, so these expressions we can write cos a minus b if the a is equal to n pi t divided by c and the b is equal to n pi x divided by c. Okay, so we can write summation over n is equal to 1 to infinity 1 over c minus c2 plus c integration over minus c2 plus c f of t, and cos, you can take out the cos is commons, n pi over c, and it is t minus x into dt. Okay, so this is expressions final if we consider cos a minus this cos a minus b. Okay, so if we expand these things, so we get like this. So this is our result. Now from this just take out the common 1 over c integrations over minus to plus c f of t dt. Okay, then we get, if we take this thing is common, so 1 over 2c integration from minus to plus c f of t dt, then into 1 plus summation over n is equal to 1 to infinity, here is a 2. Okay, the cos n pi over c t minus x into dt. Okay, so this is the expressions after we take out the commons. Okay, so if we multiply, so same here is a 1 over c, this 2 will be the cancel out. Okay, and the same result we get. Okay, so now this thing we can equate with this 1 plus 2 summation over n is equal to 1 to infinity cos n pi over c t minus x. This we can write after when we applying the limit. Okay, so here first I just write like this, n is equal to minus to plus infinity, and it is cos n pi over c t minus x. Okay, so we equate these things with these expressions. Okay, so here now summations n is equal to minus to plus infinity cos n pi divided by c into t minus x. Okay, so if I apply the limit, then we get the this c is approached to infinity, then we can write in the integration forms. Okay, so before that I like to substitute this n pi over c is equal to mu. Okay, and this implies d mu is equal to pi over c. Okay, so for that I just write this expression in this form. So these expressions you can write 1 over over 2 pi. Okay, integrations from minus infinity, after this c approach to infinity, then also we change the limit. Okay, and it is f of t dt into pi over c. Okay, this pi and this pi will be the cancel out, and the 1 over 2c. Okay, so I am just write like this. And integrations, this summation replaced with the integrations, and the cos mu into t minus x. Okay, so one more thing we can replace, that is pi over c is equal to d mu. Okay, so this pi over c we can replace. Let's just okay, now 1 over 2 pi integrations minus 2 plus infinity f of t dt. Okay, and this pi over c we can replace with the d mu. Okay, so integrations minus to plus infinity cos n into pi over c is equal to mu, so it is mu into t minus x, and the pi of, for the pi over c we can write d mu. Okay, so this is expression for the Fourier integral theorems. Okay, f of x is equal to 1 over 2 pi integration from minus to plus infinity f of t dt, and here is also from minus to plus infinity. Okay, cos mu dt minus x du. Okay, so here also we can write from 0 to infinity. So for that here is a multiply with the 2, and this 2 will be cancelled with this thing. So here 1 over pi will be. Okay, so this is Fourier integral theorems. So for this we assume the some conditions on the f of x. Okay, so this f of x integrable between this limit minus 2 plus infinity or mod f of x dx is converse. Okay, this is conditions. Okay, so it is integrable between this limit minus 2 plus infinity, and f of x is non-periodic in the limit, that is arbitrary limit minus c to plus c. Okay, and it is periodic in the out of range with the 2c. Okay, if we take the arbitrary limit, that is minus c to plus c. So these are the some condition that we assume for this f of x. Okay, so okay, we will stop here, discuss in the next lecture.